So now that you know how to identify acids, bases, and salts, let's talk about the properties of acids, bases, and salts. All right? So let's start with our acids. Okay? Let's put our bases over here, and then we'll do salts on a separate page. Okay? So, things you need to know about acids. 1, they are sour. 2, they make a pH of less than 7. 3, okay, they produce H plus ions in solution. 4, they react with metals to form hydrogen gas. You saw this in the lab. I showed you this twice or 3 times this year. So if you have a reaction like HCl and it is reacting with a metal in table J above in the table, let's say calcium, right, which is exactly what we used in the lab, you end up making calcium chloride plus H2 gas. This is now a lot of the regents question will ask you, well, how can you identify or distinguish an acid from a base? Acids, whatever acid it is, will react with a metal and will make an ionic compound and will make hydrogen gas. All right. The other thing about acids is they affect indicators. Now we're going to talk about this later, but indicators, okay, and we'll do it probably in this video. Indicators are things that will change color in response to the presence of an acid or a base, and we're going to go over that in a couple of minutes. The last thing about acids, okay, number 5, is they will react with bases. And the way that I'm going to do one is, we've done this before too, it's a double displacement reaction. So some of this stuff is reviewed, like this is a single replacement. We did these earlier in the year. Okay, an acid-base reaction is a double replacement. So let's say you have HCl, hydrochloric acid, reacting with a base. Let's say, calcium hydroxide again, another base, a metal hydroxide, right? How will that reaction occur? Well, look at the products. And here's the thing, when they do react, when the acid reacts with the base, you always get the exact same product. You get the following. You get water. The H from the acid and the hydroxide from the base, the hydronium and the hydroxide combine to make water. The other thing you're going to get is an ionic compound. The Ca, okay, is going to go with the Cl. Remember, the metal always comes first, so it's not going to be like chloride, calcium. It's going to be calcium chloride. So you're going to end up with Ca, now Ca is plus 2 and Cl is minus 1. You end up with CaCl2. I will balance this equation. Since there's 2 hydroxides, I'm going to need 2 of these, and I'm going to make 2 of these. 2 hydroniums plus 2 hydroxides make 2 water molecules. Right, so I have 2 H pluses over here plus 2 OH minuses, okay, gave me 2 water molecules, and that's how I knew I was going to get 2 water molecules. But acids always react with bases, and when they do, they always make 2 things, water and salt. Now, bases, okay, are bitter. 2, they have a pH that is going to be greater than 7. They always will increase the hydroxide content. Remember, this is hydroxide, right? And this is hydronium. And again, it's in the table. You can look it up so you don't mess it up, right? Okay? They'll produce hydroxides. 4. Okay? They will also affect indicators. That's supposed to be an A. God, the grammarians are going to come after me. They also affect changes in indicators, which we'll talk about soon. And 5, okay, they are slippery. Soap is a base, okay? Lye is a base. Shampoo contains bases. Things that are slippery tend to be basic, all right? And finally, number 6 is they will react with acids. And when they do that, they make water and salt. So if HNO3, an acid, reacts with a base, barium hydroxide, you're going to get water and a salt. And this time the salt's going to be barium nitrate, BaNO3 with a 2. And yes, we had a test on this a long time ago. And again, I'm going to balance it by putting a 2 here. So I have 2 H pluses with 2 OH minuses, and that's how I'm getting the water. By the way, this reaction of an acid and base is called a neutralization reaction. Neutralization. So acids neutralize bases, and bases neutralize acids, because when they react, they produce salt and water. However, the solution still conducts, because in both cases, as long as the salt is soluble, in both cases we have electrolytes. Acids are electrolytes. They produce ions in the water and they conduct electricity. Bases are electrolytes. And salts are also electrolytes, because bases and acids and salts produce ions in solution. Now, salts are also electrolytes, and they are any other ionic compound, as long, again, as they are soluble. If they can't dissolve in water, they cannot conduct electricity. Okay, and they can only conduct electricity when they're in aqueous solution or if they're in molten form. Now, last thing I want to talk about in this video is I want to talk to you about a bunch of indicators. So I'm going to pop up a picture of a particular table. Okay, so this table is a table of indicators. Indicators are things that change color to indicate the presence or the absence of a substance. In living environment, you learned about iodine. That was an indicator for starch. You might have learned about Benedict's solution, which was an indicator for the presence of glucose. These are chemicals that react, and when they react, they change color. Acid-base indicators are affected specifically by what the pH is. Now, I'm going to get into pH more in another video, but not right now. But for now, just a little baseline here, okay? So maybe you can remember, like, really, really simple stuff. For those who remember, 7 is usually neutral. Below 7 is acidic, right? So acids, if you put an acid in water, the pH will be below 7. And believe it or not, pH can actually be negative values, okay? Depends on, and the more acidic it is, the lower is the number. We'll explain why that is later, okay? And above 7 is basic. Now, indicators have a range over which they actually change color. And when they change color, they actually transition between colors. If you understand the first one, you're going to understand all of them, okay? And I'll give you some questions on these as well for your for like a 2-day assignment, I think, is what I'm going to do. So you see methyl orange here. You see how it has a range where it changes color between 3.1 and 4.4? So let's talk about that. For methyl orange, right, what that means is this. If you think about this like a pH scale, at 3.1, below that number, it is going to be red. So it's red below 3.1. Above a pH of 4.4, it is going to be yellow. And for those who like blending paints, the reality is what happens here is a chemical. Okay, so in between 3.1 and 4.4, it will be orange. And the reason why is this. There's actually two different substances. The indicator is reacting to the presence of acid or base. So when it's very acidic, it reacts and it turns red. When it turns towards basic, it turns yellow. Between 3.1 and 4.4, both forms of the chemical are present. So when you have some of the orange molecules there and the yellow molecules there, it looks orange. So let's see if you understand this chart by just giving you an example. Let's say the pH is 5, right? So we have a pH of, let's say, 5, all right? So what does that say about, let's go through each of the indicators and see which color it would be. So if the pH of a solution was 5, then that would be you probably have an acid. Let's say you had a solution with HCl, right? If you had a solution of HCl in which the pH was 5, now it's an acid solution, right? What color would the indicators be? Well, for bromothiamyl blue, it would be yellow. For phenolphthalein, it would be colorless. For litmus, it's in between here, isn't it? So it would probably be somewhere between red and blue. Purple. For Brom-Kressel green, 5 falls between 3.8 and 5.4, so it's right in the middle. So it wouldn't necessarily be yellow or blue. It'd be a mixture of yellow and blue molecules, which, when you do paint, it would be green. But for thiamyl blue, it's below 8. Because it's below 8, it would be yellow. Let's do this one more time, just make sure we understand it all. I'm going to erase all the writing on there, okay? So let's say we added, some NaOH. Now, why am I saying NaOH? Because NaOH is a base, and that would give us a pH above 7, right? Assuming we didn't have something else in there, right? Okay, so let's say we put just a little bit of NaOH there and we get a pH of 8. That's slightly basic. Okay, what colors do we have? Well, methyl orange at a pH of 8 would be yellow. The bromethumb blue, H is above 7.6, would be blue. At a pH of 8, okay, it would be light pink. Just turning pink. Just start to turn, so a little teeny tinge of pink. The litmus would still be purplish, but probably be more blue. The brom crystal bean would be just blue. And the thymal at a pH of 8, would still be yellow, just beginning to turn blue.